Hi everyone, this is Stalin. I am glad to welcome you all to our YouTube channel. Today, I am going to teach about common ion effect. Before that, we have to know how acids are classified. We know in the previous section what is the concept of acid and bases. Okay, fine. Today, first of all, we have to know the classification of acid and bases. So, acids are classified into two types. One is strong acid and another one is weak acid. What is strong acid? Strong acid is completely ionized in water, whereas for weak acid, which is partially ionized in water. What is strong acid? Completely ionized, completely dissociated in water, whereas weak acid partially dissociated in water. Fine. See, what is strong acid? Which is completely ionized in water. Let us take hydrochloric acid, which is dissociated into H3O plus ion and Cl minus ion. See here, the arrow mark indicates the single direction, which means the reaction is completely taking place in one direction. What about the next one? Sodium hydroxide. Sodium hydroxide dissociated in water to form a Na plus and OH minus ion. So, both hydrochloric acid and sodium hydroxide completely dissociated. For that, there are belongs to strong acid and strong base respectively. Then, what about weak acid and weak bases? Weak acid and weak bases are partially ionized in water. For example, acetic acid. Let us take acetic acids which dissociated into acetate and H plus ion. See, here there is a equilibrium symbol is there. There is a two-way symbol is there, which indicate the reaction taking place both forward and backward reaction. This reaction never complete any one direction. Such kind of reactions are called a reversible process. So, in this reaction, acetic acid does not completely ionize in water. Similarly, ammonium hydroxide. Let us take ammonium hydroxide, that is also not completely dissociated in water. See, ammonium hydroxide dissociated into ammonium ion and hydroxide ion. So, here also there is a reversible process taking place. Okay, then right. So, what is the common ion effect? We know weak acids and weak bases are partially dissociated in water, partially ionized in water. Okay. Now, let us take acetic acid. Acetic acid is a partially ionized in water by adding sodium acetate. Sodium acetate is a strong electrolyte which completely ionized in water. See here, sodium acetate completely ionized in acetate ion and Na plus ion. So, this salt is added to the acetic acid. Now, the degree of dissociation, that is splitting of acetic acid into acetate and H plus ion is reduced. That is suppressed. So, the suppression of degree of dissociation of weak acid or weak base by adding common ion in it, that is called a common ion effect. So, clear students? So, what is common ion effect? The degree of dissociation of weak acid or weak base is reduced further by adding common ion in it. That is called a common ion effect. Clear? Right? So, once again I repeat you. So, acetic acid is a weak acid which partially dissociated into water, partially dissociated into acetate and H plus ion in water by adding acetate, sodium acetate to the acetic acid. The degree of dissociation of acetic acid is further reduced. It is already partially dissociated. By adding sodium acetate, the degree of dissociation of acetic acid is reduced further. That is called a common ion effect. Why it is taking place? Why the degree of dissociation of acetic acid is decreased? So, which is explained by Le-Chatelier principles, which is explained by Le-Chatelier principles. What is Le-Chatelier principles? When a stress is applied to the system at equilibrium, when a stress is applied to a system at equilibrium, the system adjusts itself the stress to nullify the effects of stress or disturbance. That is called Le-Chatelier principles. Here we can add sodium acetate. Sodium acetate produces acetic ion. That acetate ion is the common ion for both acetic acid and sodium acetate. So, which increase the concentration of acetic acid. By adding sodium acetate to the acetic acid, acetate ion concentration is increased. So, according to Le-Chatelier principle, the system adjusts itself. The system adjusts itself to nullify the effect of disturbance or stress. Okay, so here the acetate increasing concentration of acetate ion which takes place, the reaction takes place in reverse direction. See, equilibrium will shift towards the left hand side of the arrow mark. Okay, that is a reactant is formed. So, the formation of product is decreased, that is the degree of dissociation is decreased. So, in other words, the degree of dissociation of acetic acid is suppressed. Okay, so this is known as common ion effect. So, what is common ion effect? Degree of dissociation of weak acid or weak base is decreased, reduced, suppressed by adding common ion in it. That is called a common ion effect. Clear? Next one is, we know pH. pH is one of the measurement to identify or determine the acid or basic nature of the solution. The pH value is less than 7 mean, which indicate the solution is or the substance is acidic in nature. If the pH value greater than 7 mean, which indicate the substance or compound is a basic in nature. Okay, here the water, let us take water. Water is a neutral substance. Water is a neutral substance. It has the pH 7. The value pH 7 mean, which tells about the solution is a or substance is the neutral solution. Okay, now by adding a small amount of acid to the water, the pH value is decreased. That means the pH value tends to below 7. Okay, which indicate the solution become acids. Okay, then suppose we can add small amount of bases to the water. The pH value is increased, which increases above 7. Clear? By adding acid to the water, the pH value is decreased below 7. By adding bases to the water, the pH value is increased 7. So, above 7. So, which indicate the solution is a basic in nature. But in some solution we can add small amount of acid or bases. The pH value remains constant. Such kind of solution is known as buffer solution. So, what is buffer solution? A small amount of acid or bases added to the mixture, the pH value remains constant. The pH value does not alter, which remains constant. Such kind of solutions are called buffer solutions. So, what is buffer solution? The pH of the solution remain constant after the addition of small amount of acid or base. Such solutions are called buffer solution. Okay. So, buffer solution. Next one is type of buffer solution. Buffer solution may be classified into two types. One is acidic buffer, another one is basic buffer. So, what is acidic buffer? Weak acid and its salt. weak acid and its salt is called as a acidic buffer. For example, acetic acid is a weak acid and its salt, that is called a sodium acetate. This mixture is called a acidic buffer. Then what is basic buffer? Basic buffer is nothing but weak base and its salt. Weak base and its salt. For example, ammonium hydroxide and ammonium chloride. Ammonium hydroxide is a weak base. Ammonium chloride is a salt of the weak base. So buffer solution classified into two types. One is acidic buffer, another one is basic buffer. Next one is buffer action. Buffer action. So the reaction which maintain the pH of the solution remains constant. Such actions are called buffer actions. So what is buffer action? The reaction which maintain the pH of the solution remains constant, that is called a buffer action. Okay, so here let us take acetic acid. So acetic acid is a weak acid which is dissociated into acetate and H3O plus ion. By adding common ion, that is sodium acetate, to the acetic acid which produces acetate and Na plus ion. Here the CH3COO minus ion is considered as a common ion. Okay, so this is an example for acidic buffer. This is an example for acidic buffer. Okay, by adding acid. What is acid? Already I told the previous section. What is acid? Acids are the substances gives H plus ion. So we can add acid, that is H plus ion. That H plus ion combine with acetate ion to form a acetic acids. So in this mixture we can add acid. The H plus ion is produced. That H plus ion combine with acetate ion to form a acetic acid. That is a reverse reaction only taking place. So the pH of the solution remain constant. The pH of the solution unchanged by adding H plus ion. Okay. Alternately, we can add base. What is base? Base is the substance which gives OH minus ion in water. So here the OH minus ion, that is base, added with this mixture, this acidic buffer. What is happening in this mixture? That OH minus ion combine with the hydronium ion, H3O plus ion, to form a neutral water. So the pH of the solution remains unchanged. So by adding acid or bases, the pH of the solution remains constant. That is called buffer solution. The reaction which maintain the pH of the solution as a constant, that is called buffer action. Clear? Clear, viewers? I hope all are understood about the common ion effect and buffer solution. Okay, thank you very much.